Explore the power of concurrent and parallel execution in Python to build faster, more responsive applications. We'll delve into multithreading and multiprocessing, key techniques for optimizing performance and efficiency in your Python programs. In this chapter, we delve into the concepts of concurrency and parallelism. We'll explore how these techniques enhance performance by allowing tasks to execute simultaneously or in an interleaved manner. Understanding these principles is crucial for optimizing Python applications. Concurrency allows tasks to progress by interleaving execution on a single processor, creating an illusion of simultaneity. Parallelism, however, involves tasks running simultaneously on multiple cores, achieving true simultaneous execution. In Python, multithreading facilitates concurrency, while multiprocessing enables genuine parallelism. Multithreading and multiprocessing enhance application responsiveness by keeping interfaces interactive during background tasks, preventing user interface freezes. They improve throughput by efficiently processing multiple tasks, maximizing resource use, and reducing execution time. Multiprocessing overcomes Python's global interpreter lock, crucial for central processing unit-intensive tasks, while multithreading efficiently handles input/output bound operations. Python's threading module allows multiple threads to run concurrently within a single process. Each thread operates independently, sharing the same memory space, which facilitates data sharing but necessitates synchronization. Threads are ideal for I/O-bound tasks, such as file operations and network requests, where they can efficiently manage waiting times and improve application responsiveness. A thread in Python is an independent execution flow within a process, allowing concurrent operations. Threads share the same memory space, necessitating synchronization to prevent conflicts. Each thread has its own stack and registers, maintaining execution context. Threads are ideal for I/O-bound tasks like file operations and network requests, where waiting time is significant. The Python threading module offers a high-level interface for thread management. Create threads using threading. Thread with a target function. Start execution with .start and ensure completion with .join. Utilize synchronization primitives like locks, events, conditions, and semaphores to manage thread access and avoid race conditions, ensuring efficient and safe concurrent operations. In a single process with multiple threads, all threads share the same heap memory, facilitating efficient data sharing. Each thread has its own stack for local variables, preventing conflicts. CPU registers store execution states separately, enabling smooth context switching. Threads execute the same code segment, minimizing memory overhead compared to separate processes. Using Python's threading module, we can run two tasks concurrently. By creating threads for each task, they execute simultaneously, interleaving their outputs. This concurrent execution reduces the total time to approximately 2.5 seconds, as sleep periods overlap, showcasing efficient multithreading in action.